In today's video, we're going to discuss Google's newly launched Gemma model, which is considered to be the new state-of-the-art open models that are out there. Prima facie, it looks like a promising model. Google categorically states that Gemma is a family of lightweight state-of-the-art open models built from the same research and technology which is used to create Gemini models. Although these are smallish models having 2 billion and 7 billion parameters. But as per Google, these models still achieve best-in-class performance for their sizes compared to other open models because of their relation to the larger Gemini family in terms of technical and infrastructure components. In terms of sizes, there are two sizes which are released for Gemma. First one is the 2 billion parameter model, other one is the 7 billion model. And both of these models have a base variant and an instruction tuned variant. So altogether there are 4 models that are released as part of this. In comparison to the previous state of the art, which was Llama 2, as we can see over here in this technical report, Gemma is way ahead of Meta's Llama 2 on all of these capabilities, namely general, generation, reasoning, math and code. The point which is most fascinating to me in this particular report is that Gemma with 7 billion parameter is scoring way ahead of Llama 2 having 13 billion parameters across all of these capabilities, which is cool, right? In this particular video, guys, I'm also going to show you how to perform hands-on with Gemma. And for consuming these models or for performing inferences with them, we can either use Colab, we can use Kaggle, or we can also do that on Hugging Face. Another point which is fascinating is that Google says pre-trained and instruction-tuned Gemma models can run on your laptop. Of course, it needs to have some bit of minimal set of hardware in terms of GPU acceleration, but yes, you can do that. Now at this point, I think we are ready to get into the hands-on part, where we will give in some toy prompts to Gemma and see how the generation looks like. We have these 3 options: Colab, Kaggle and Hugging Face. I have them open over here. Colab is having the Python code, we can use that. We also have Hugging Face as an option. We can draw inference over here, but before that you will have to log in to Hugging Face environment or sign up if you don't have an account, and you will have to accept Google's terms of use, right? Same way, if you go to Kaggle, again on this platform too, you will have to apply for access to using Gemma, and don't worry about it, you will get instant access. It's just that you will have to accept to the terms of use agreement that Google will put up for you. Between the 3 platforms, I'm going ahead with Kaggle because it looks quite clean to me. I'll just quickly sign into my account. If you don't have an account, you may create one. Alright, in my case, I've already consented to the license for Gemma. You may do that too. And thereafter, once I scroll down in this particular page, I see this particular option to choose a variation of Gemma. Over here, we have 4 different variations of Gemma: the 7 billion instruct, 2 billion, 7 billion and 2 billion instruct, right? So for our inference, let me choose the 7 billion instruct, and below we'll have this place to do inference, right? First of all, they have these few options to choose from. Let's say I say explain quantum physics in an easy way. Let's see what we get. And because we said explain in an easy way, that's why the model is explaining quantum physics to us through the help of an analogy, which is cool, right? And one point to remember here is that because the output is maxed at 128 tokens, so you might not get the full response that is generated. So let's be aware of that. Now, for doing this inference in a systematic way, I have this bunch of toy prompts that I have compiled. Let's start with the basic level. What is the meaning of life? On this, all I expect is a sort of logical answer coming our way. Let's see what we get. Alright, the model says life is a complex and multifaceted question that has captivated philosophers, theologians and scientists alike for centuries. So it's a very complicated sort of an answer. Can I just say explain in simple terms? Let's see what we get. The meaning of life is to experience joy, happiness and fulfillment through personal growth, meaningful relationships and contributing to the world. See, if we keep things simple, we get senseful answers, right? Let's move on to the next prompt. It says if a shirt costs $25 and there is 20% discount on it, what is the discounted price? So it will be $20. Let's see what the model says. And rightly so, the model also does the calculation for us and finally tells that the shirt will cost $20. Fair. Now, I have this third question. If a car travels at a speed of 60 miles per hour, how far will it travel in 3 hours? This sounds again like similar to the previous one. Let me move on to the intermediate level questions now. First is, give me a diet plan for Indian vegetarians for 7 days, 5 meals a day, breakfast, snack, lunch, then snack, and then dinner. So a lot of stuff we want to eat. All right, so I'll put this prompt. Again, let's be aware of the fact that because there is a cap of tokens of 128, so we won't get the full answer. It's just to sort of see how the model behaves, right? And as we can see, we ask for 5 meals for the day, and the model is in fact giving us 5 meals. And for Indian vegetarian, I see all the vegetarian options that are being thrown at us, right? Vegetable samosa is not a healthy snack. Okay, so because I didn't say healthy snack, right? If I say healthy diet plan, I need a healthy diet plan. Okay, now samosa is out of here. See, again, so simple. Now let's move on to the next problem. If a number is increased by 20% and then decreased by 20%, what is the overall percentage change? So simple answer to that would be that, let's say number is X. If I increase it by 20%, then I decrease it by 20%. The final number should be 0.96x, right? Now let's see what the model says. I'll just copy this prompt here. Let's see what we get. Alright, so the model is thinking in the right direction. It's just that because the output is capped to 128 tokens, that's why the entire response is not getting printed. Let's just say, just give me the answer. Oops, it makes a mistake there. What if I say, just give me a one-line response? Let's see what we get. Okay, so it's making a mistake over there. If I'm asking it to curtail its response, the model is not thinking in a systematic manner. So on this particular problem, we are not getting a satisfactory response. So yes, intermediate level aptitude question are sort of a problem. All right, let's move on to a coding question now. Write Python program to compute factorial of a number. Let's see how good Gemma is at generating Python code. I think the program is written all right. It's just that it's not formatted well. Let me try generating it again. Okay, this time we are getting well formatted response, and this looks fair. Alright guys, this was a quick video on performing inference with the new Google's Gemma model. Do try it out on your end and share what kind of feedback you have about the model. If you like our work, do give this video a thumbs up and subscribe to our channel for more interesting data tech content. See you in the next video. Bye.